All right, students, we're ready for section 7 of chapter 2, where we're going to talk about translations and reflections. Last year, I know in Miss Wood's class, you all did some tessellations. Do you all remember doing tessellations? Yes. Okay. When you made a tessellation, you were doing a translation. You made a shape, and then you would slide the shape across your paper. So a translation is an image. It's when an image is the same shape, the same size, and it just gets slid from one position to another. And the orientation is always the same as the original figure. So now we're going to skip the next little bit of information and jump down to look at a translation. Rectangle MNOP is shown at the right. If it is translated 4 units to the left, translated 4 units to the left, when you are moving on an XY coordinate plane and you move to the left, what are you moving? Positively or negatively? James, when you move to the left on an XY coordinate plane, are you moving positively or negatively? Negatively. Okay, then it says, and 5 units up. Abby, if you're moving up on an XY coordinate plane, are you moving positively or negatively? Positively. Say it loud so you can be picked up on the recording. All right. Left and right, is that my X or my Y? Reagan? X. That's your X. Up and down, is that my X or my Y, Allie? Y. Y. So I am going to take the original M, N, O, and P, and here's going to be the math. This is the math that is involved in a translation. A lot of students like to just use the graph, but sometimes you're going to have problems where they don't provide a graph. So let me show you the math involved. If your original M is 1, -1, and we're translating it, James said, to the left, which is -4, and we're translating it up, which Abby said is +5, then watch what happens to my X. My X was 1, and I'm going to move it to the left 4, so add -4. This is X. And my Y was at -1, and I'm going to add 5. And that's where they got the new number, the new coordinates of M. 1 plus -4 is -3. -1 plus 5 is 4. And this new number, we call it M prime. Whenever you see the M with a little tick mark or apostrophe, it's pronounced M prime. If you prime an engine, do you replace the engine? No, you just tweak the engine to make it run a little bit more smoothly. We've tweaked M, we've made it M prime. N becomes N prime, O, O prime, P, P prime. So for each one of those, if you can look at the math, you started with 4 and you added -4. Guess what your X became? 0. You started with -1 and you added 5 and you end up with 4. So they've already done the math for us. Let's go and graph this image on our XY coordinate plane. So I'm going to pause the video. You graph. So when you plotted the points that they've already figured out for you, you'll see that your original rectangle slid to the left 4 units and up 5 units, and there's your translation. So now try exercise number 1 on your own. I want you, though, to do the math. Don't just use the graph. Please show your math in the area at the bottom. So, AJ, what are the coordinates of R?
3 to the right and 3 up.
So 3, 3. And the coordinates of S, Caroline, say them loud. One more time. 4 and 1. And the coordinates of T, Fozzie?
2, -2.
2 and -2. And what did our instructions say? We're going to translate this 6 units to the left, which means what, James? We're going to go left negatively, right? And 3 units down, which means what, Abby? Down. Down's going to be negative. Okay, so Pay attention to whether you're going up or down, left or right. So you take the original x and you have to go to the left 6. Whoops, I didn't need a comma there. And the original y and go down, so negative 3. The original x minus 6 and the original y minus 3. That's the math involved in getting the prime coordinates. So raise your hand if you have r prime. Alex, what did you get for r prime?
-3, 0.
Very good. And Drake, s prime?
-2, -2.
Very good. Addison, t prime?
-4, -5.
Very nice. Now let's go up here and plot the points and see what our translation looks like. Okay, so you'll see your triangle got slid to the left 6 and down 3. All right, go back up to the top of your page where I skipped over some information called a reflection. All right, whenever you think about your reflection, what do you immediately think about, Caroline?
Myself.
Yourself? Seeing yourself where? In a mirror. Good, Mason. So a reflection is a mirror image. You always think of a mirror when you hear the word reflection. All right. In math, though, we call it a flip. So if a translation is a slide, a reflection is a flip. And it's the same shape and the same size, but we have a different orientation. So if you flip over to the back, I'm going to show you what a reflection looks like in pre-algebra. Know that they're going to get more complicated when you see these again in algebra. They do look complicated, don't they? In reflections, there's always a line of symmetry. Good news for you, in our class, the lines of symmetry are always going to be the x-axis or the y-axis. Okay, so see how this rectangle is exactly the same on both sides, and this rectangle is exactly the same. It's like you did in elementary school when you would do that ink blots, and you'd fold the paper and you'd unfold it, and it would be the exact same on both sides. However, I don't know about you all, but mine always looked like a butterfly. So if I did a big ink blot and a little ink blot, and then I folded it across the line of symmetry, I would end up with a little ink blot here and a big ink blot over there. And mine always, did I already say that, looked like a, what did I say? A butterfly. See the butterfly? I can make a little butterfly out of that. Yeah. Butterflies are God's reflection. He was able to do that, on most all butterflies. They have the exact same patterns on both sides. Okay, so squared, right-angled rectangles are easy to do, but look at this reflection down here in example 1. Those parallelograms look more like my butterfly, don't they? Because they're a little bit more interesting, so they go in opposite directions. So that's why you have to be careful. The difference in a translation, my parallelogram would still be pointed this direction. If this was a translation and I slid it down, it would still be going in the same, my top point would still be my top point. But for a reflection, it's the mirror image. Now, reflections are easier. Listen to this. 2 things you have to watch for when you read these problems. Was it a reflection or a translation? And if it's a reflection, here's why it's so easy. Look for, was it reflected over the x-axis or the y-axis? Because look, if it's the x-axis, the x coordinates stay the same. That's easy. There's no math involved. The y coordinates, though, you're going to write down the opposite. So 1, 3, 4, and 2 all stayed the same. 1, 3, 4, 2, 1, 3, 4, 2. And then for the y, because I reflected over x, x stayed the same. Y's become the opposite. So -1 becomes +1, -2 becomes +2, negative 4, positive 4, negative 3, positive 3. So when we go to do one on our own, let's read it. JKLM have these coordinates. Graph the figure and its image after a, wait, what was it? A reflection over the y-axis. Y'all are a smart group. Raise your hand if you can tell me what's going to stay the same. When it reflects over the x-axis, the x stayed the same. Reflected over the y-axis, Hunt, what's going to stay the same? The y is going to stay the same. So the first thing I'm going to do is I'm going to write down J, do this with me, K, L, I'm not JKN, I'm serious, and M. And we are reflecting, so we're going to have some prime, J prime, K prime. We're tweaking it. We're going to change it. And Hunt just told us what stays the same? The y, not the axis. Of course the y-axis stays the same. The y coordinates. So I'm going to just go through and copy down negative 2, negative 2, negative 4, negative 4. Because those are my y coordinates right here are going to be my y coordinates right here. What do I do to the x values? Who thinks they know? Mason? Flop's not a very mathematical term. Kennedy, what do I do? The opposite. So if it's negative 4, I'm going to write down what, Kennedy? 4. Negative 2, 2. Negative 1, 1. Negative 5, 5. All right. So now we have a task. We've got to plot our original and our new coordinates and see if they reflect. Let's do that. Okay, so hopefully you've had time to graph the original JKLM, and let's check our prime and see if we think it made a reflection. So J prime is at positive 4, negative 2. J prime. K prime is at 2, negative 2. L prime is at 1, negative 4. And M prime is at 5, negative 4. And there's another trapezoid. And notice the L's are closer to each other, the M's are farther away, because when you fold, it's like taking it and folding a piece of paper like an ink blot. This rectangle is going to make the exact same shape on the other side of the y-axis. We were folding it about the y-axis. Sometimes it's the x-axis. If it's x-axis, your x value stayed the same. But for this one, our y value stayed the same because we were going across the y-axis. I have some practice problems I want you to try when you get to class tomorrow. Mason has a joke to leave you with.
What happened to the plant in math class?
I don't know, Mason. What happened to the plant?
It grew square roots.